Hello, welcome back to my workshop. Right, a viewer writes, a viewer called Optimus Prime, on the review of this particular welder, to ask how exactly, or would I recommend it for thick steel and thick rods. And by thick rods we mean 4mm and 3.25. He asked for half-inch steel. Don't have any half-inch. Got a 12mm, and what we are going to do is do a TIG weld on some T-butt on like that. This is unprepared in terms of grinding back this. If you were doing it like this, it would be pretty lunatic to do that, but that's not an untypical joint. What you typically do for that is you would chamfer these about 45 degrees both sides, and then you would be able to weld all the way through. We're just going to do a T, and we're going to see how hard it does it, how well it does it. Going to do tack 4 corners, then we're going to run a 4mm down there and a 3.25 down there, and in order to get a good penetrating weld you do have to go very slowly and put quite a lot of stick in there. So that's what we're going to do now. The first thing we're going to do is I'm going to clamp it together to put the tacks on. Sit down there like that, and then I'm just going to tack weld it. Because that way it can't move while I'm tack welding it. Down for a sec. The tacks are going to be quite heavy. Right, and I'm not going to be using the recommended settings on the actual unit. I'm going to be using about 120, 130 amps or 3.2, and I'm going to be using 160 or more for the 4. So, let's put gas on. Well, that's 130 amps. Right. Okay, so that's set to 170. Hopefully this doesn't blow any fuses. Right, that was 170 amps. And a 4mm rod. As well, that looks alright. Right. So what I'm going to do, I'm going to rewrite 4mm on that side because that's got quite warm. Oh no, it's still there. Just. Right, 3.2mm or 3.25. We're going to turn that down to 130. Okay, so we're running this at 130, we're burning it hot, and the reason why we're burning it hot is because we're welding very thick steel. I am quite happy with that weld. Right, so what's going to happen now? So I welded that side 4mm 70 amps, 170 amps. This side 3.2 with 100 and what was that? Right, 130. So what we're now going to do, just rewrite that. So I'm going to let that cool down and let the smoke clear. And incidentally, when you've just welded a piece of steel that's 12mm thick, gloves aren't going to... You won't be able to pick it up with gloves. It'll be too hot. So I'm going to come back in a minute, or at least I'm going to come back quite a long time later and cut a couple of slices off this so we can see how that weld did. Crikey, that is... I actually like the 3.2 a lot better than I like the 4. I think instead of 170 amps I could have really pushed that up, because if you look here, it might just be the way I was welding it, but if you look there, that's not flowed nicely around that corner, so that's too cold there on the 4 side, whereas that has flowed into it a bit much better on that side, and you can see where it's melted right up in there. So that kind of current, I think I'd probably go with a if I push this to 180 amps on a 13 amp supply, it's going to blow a fuse. So I quite like that at 3.2s for that thickness. Anyway, right, back in a minute. Right, so one way or another I've cut it in half. Let me show you the other bit. It might be a little bit slightly more useful, and the problem of course is it's very difficult to see exactly where the bit in the middle is. Actually, it's not that hard to see here. You can just about make out if you're very careful. But what I'm going to do is I'm going to put a bit of blue on this, which I've milled nice and flat, and then I'm going to stick that on a bit of very fine emery paper and rub all the marks off. Let that dry, then I rub all the marks off, and when I've rubbed all the marks off, it should run down into the crack that's left between this piece here and this piece here, and then make it easy to see where the fault line lies. So I shall go and do that, and I shall be back in a sec. Right, so we're sort of done. I've cleaned that up. It's actually very hard to see exactly where that is on camera, but I'll come back to that in a sec. You might find an easier job of seeing where there's a line across there, if I can catch that in just the right sorts of light. And I might also just bring that up. So that's the 4mm side, okay, where it hasn't bonded particularly well into there, and the line goes further across there, and that's the 3mm side. Has to be said, as far as I can see from my very non-expert eye, that looks like a perfectly good weld. We'll come back to that. Okay, so if we go on to this, if I could just... So on this one, this is the 4mm side, and you can see there that there hasn't been anything like enough heat dropped into this base metal here, whereas there's been more heat dumped in over there. And the net result, if I can just tweak that in the right level of, catch it in the right light, you might be able to see it. I'm going to go and see, actually, give me a second, just get my camera out and see if I can take a picture of it. In exactly the right light. There we go. There we go, that'll do. Right, I think you can see it reasonably plainly in there. Okay. Yes, you can. So that's good. Right, so we'll put that picture up. But basically, if you look here for your delight and delectation, what I've done is I put a little green dot at either end of where it's gone. So what I've done is I've firstly put here pretty much equal heat there and there, and that's melted the weld into both reasonably well, okay? And there I haven't. I put not enough heat into this bit here. I've also really gone too fast down both welds, and what I should have been doing was dumping a lot more heat on both sides to break that across, because if you look there, if I just go and get my pointy stick, right, so if you look here, we're running from there, which is almost in line but slightly inboard from here, and over here we are there, which is actually slightly outboard of this. Yep. So firstly, it's actually easier to get a lot of heat into the weld with a lot more, with driving a thinner rod harder than it is having a thicker rod driven slightly harder, if you see what I mean. So that's quite interesting. I'm going to go, and that's listed as a first practice weld on very thick stuff. I'm going to go and have another go at that another point, and obviously do another film, which might aid Optimus Prime. The other thing I'm going to say to, oh, and something you can see here, by the way, a slight error in the welding here. If you look along here, there are undercuts here, 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 and here, where I've melted very hard into this surface here. So there's no doubt we're penetrating with quite a lot of heat. But ultimately speaking, this is quite good for a static load. This will work for a static load reasonably well. But what will happen if you've got this on some kind of vibrational load is that this crack here between these two pieces of metal will start to spread, because it's got a hard point at either end, a sharp point at either end. And over time, if this is under a shock load, if you could imagine being some kind of chassis member or something like that, that crack will spread, and then it'll get towards the surface of these welds, and the weld will fail. Right. One other thing, I do have another quite interesting welder turning up at some point soon. It cost me about 500 quid, which is quite a lot of money, really. That one has the same sort of power as this. Only problem that it's got, actually it's got more, only problem I've got is I can't drive it anything like as hard as I'd like to be able to, because it ideally would like a 32 amp supply. Haven't got that. What it has got is the ability to TIG, MIG, gasless MIG, arc and plasma cut. So that'll be an interesting toy. That will be coming up when it arrives in a few weeks. Thank you very much for watching. Please like, please share, please subscribe. Any comments? Welcome.